Hello everybody, I am here with the continuation of class 9 physics, chapter force and laws of motion. Today we are going to discuss Newton's third law of motion. In the previous classes we have discussed first law of motion and second law of motion. So now today it's the turn for Newton's third law of motion. This is the easiest law of Newton. Newton's third law of motion states that for every action there is an equal and opposite reaction. You might have heard it also. In some other context you might have heard it. For every action there is an equal and opposite reaction. What is meant by action and reaction in physics? If I expand this idea, I may state it like this. The force exerted by first body on the second body will be always equal to the force exerted by second body back on the first body. This force exerted by the first body on the second body is called action. Then the force exerted by second body back on the first body is called reaction. So action is equal to reaction. This is Newton's third law of motion. I repeat, the actual statement must be like this. Newton's third law of motion states that the force exerted by a body on another body is always equal to the force exerted by the second body on the first body. Or in short we can say, for every action there is an equal and opposite reaction. There are so many examples around you to explain Newton's third law of motion. Have you heard about recoiling of gun? When a bullet is fired from the gun, especially a rifle, the gun moves backward. It will give a jerk. Those who have fired might have felt it. You can very easily feel that heavy jerk back on your body when a bullet is fired from a rifle. So the force by which bullet is moving forward is called action. The force by which the gun is moving backward or exerting backward is called reaction. So it is because of the force of the bullet that the gun is coming back. This is called recoiling of gun. Another example you might have felt when water flows through a pipe, hose pipe, with great force, especially that small hose pipe that we use to water the plants. When water pushes out suddenly through the pipe, did you notice that the pipe moves backward? Yes, it will. So the force by which water moves out is action. Now, the water is exerting a force back on the pipe. That's why pipe is moving backward. That is reaction. Same reason why the firefighters are holding that hose pipe very tightly. Or two people are involved to hold a pipe, the water pipe of the fire engine. Otherwise, the pipe will exert such an emerging force backward so that one fellow may not be able to handle it. So action, the force exerted by the water in the forward direction. Reaction, the force exerted by the water on the pipe due to which pipe moves backward. Another example, you might have seen the rockets. Rockets are going upward. Do you know the actual force behind this rocket? It is, you know that a fuel is burned in the rocket. When the fuel is burned, lot of hot gases are produced. These hot gases are coming downwards. It is pushed downwards. That is action. Due to this force exerted downward, an opposite force will be acting on the rocket upward. That is reaction. So the force by which hot gases are coming down is equal to the force by which the rocket is moving upward. Action, reaction. Another example, if you jump out of a what is called this one boat in water, you are jumping out of the boat to the land. Did you notice that the boat moves backward when you jump forward? You will reach on the land, but the boat will move little backward. Your jumping forward is action. The boat goes backward is reaction. Another simple example, when we are walking on the ground, again there is Newton's third law of motion. Did you notice that when we are walking on the ground, actually we are pushing the ground backwards. When we push the ground backward with our feet, the ground is pushing us forward. The force by which we are pushing the ground backward is action. Then the ground pushes us forward, that is reaction. So action is equal to reaction. There are so many examples to illustrate Newton's third law of motion. So in short we can say Newton's third law of motion states that for every action there is an equal and opposite reaction. I explain once again. Action means the force exerted by the first body on the second body. Reaction means the force exerted by the second body on the first body back. So that's all about Newton's third law of motion. Now using this Newton's third law of motion, I am going to explain one more phenomena called law of conservation of momentum. Law of conservation of momentum. I hope you remember the word momentum. Momentum is the product of mass and velocity. Now listen carefully, what is law of conservation of momentum? To conserve means to protect. So momentum is conserved. See how? Let us suppose a body of mass m1 is having an initial velocity u1, is moving forward, and another body of mass m2 is moving with an initial velocity u2. Suppose u1 is greater than u2. That means the velocity of the first body is greater than the second body. So if they are moving in the same path, straight line path, after some time the first body will collide with the second body. Suppose after a time t, this m1 and m2 collide with each other. During this collision, suppose the first body exerts a force F1 on the second body. By Newton's third law of motion, then the second body will also exert the same force back on the first body. I am calling it as F2. So F1 is the force exerted by first body on the second body. Then the force exerted by second body on the first body is F2. Suppose after the collision, the first body of mass m1 is moving with a velocity v1 and the second body m2 is moving with a velocity v2, and the time of collision is t, small letter t. So this is a very important derivation. Before you start the derivation, you have to draw it and you have to write a short description about the activity. What will you write? Let a body of mass m1 is moving with an initial velocity u1, full stop. Let another body of mass m2 is moving with initial velocity u2. Let u1 is greater than u2. Then the first body will collide with the second body for a time t second, during which the first body exerts a force F1 on the second body, and then the second body will exert the same force F2 back on the first body. After the collision, let the first body moves with final velocity v1 and the second body moves with final velocity v2. You have to write this paragraph first. Okay, now continue. We know that using Newton's third law of motion, F1 is equal to F2. Action is equal to reaction, or force exerted by first on the second is equal to force exerted by second on the first. But this time we will put a minus sign also here. Why? See the direction. The direction of force F1 is this, and the direction of force F2 is reverse. Whenever the direction of force is opposite, we will show it with a minus sign. Remember always, if the direction of both the forces are same, then we will take both in positive. Not only force, even in velocity also. If the velocity of the first body is in one direction and the velocity of the second body is in the opposite direction, then the second body's velocity will be taken with a minus sign. Similarly for force also. So by Newton's third law of motion, F1 is equal to minus F2. Now by Newton's second law of motion, so here you can write using Newton's third law of motion. F1 is equal to minus F2. Now, using Newton's second law of motion, what is F1? F1 is equal to rate of change of momentum. Is it? Second law states that force is directly proportional to rate of change of momentum. So what is F1? Force exerted by the first body. So what will be the rate of change of momentum of the first body? Final momentum minus initial momentum. That is m1 v1 minus m1 u1 upon t. Final momentum minus initial momentum upon time is called rate of change of momentum, is equal to minus, what is F2? m2 v2 minus m2 u2. m2 v2 minus m2 u2 upon t. Here you can write using Newton's second law of motion. Okay. Now this t and t got cancelled. Open the bracket. There is a minus sign outside, so it is minus m2 v2 minus minus plus m2 u2. Here we have m1 v1 minus m1 u1. Now I am keeping u1 and u2 in one side, v1 and v2 in another side. Shifting this m1 u1 to RHS, and I am taking this m2 v2 to LHS. So we have already m1 v1 here. Minus m2 v2 will become plus m2 v2. I am shifting this to RHS, so it will become m1 u1 plus m2 u2. Please see this. We got m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. What is m1 v1 plus m2 v2? m1 v1 final momentum of the first body, m2 v2 final momentum of the second body. So plus means what? Total momentum of the two body after collision. So total momentum, the plural of momentum is momenta. So total momenta after collision is equal to, what is m1 u1 plus m2 u2? m1 u1 plus m2 u2. Total momenta of the same two bodies before collision. So total momenta before collision. So what is the conclusion? We got m1 v1 plus m2 v2 is equal to m1 u1 plus m2 u2. Means total momenta of the two bodies after collision is equal to total momenta of the same two bodies before collision. What does it mean? Momentum is conserved. Momentum of the two bodies is not lost anywhere. The same momentum is conserved before collision and after collision. So momentum of the two bodies is conserved or remains constant before collision and after collision. So momentum is not lost anywhere. That way it is called law of conservation of momentum. I repeat, law of conservation of momentum states that total momenta of two bodies before collision will be always equal to total momenta of the same two bodies after collision. So this derivation is very important. Before you start the derivation, I told you have to write the description about the bodies and their masses, initial velocity, final velocity, forces. So that's all with chapter 2, force and laws of motion. The second chapter also got over. Now we will come with the question answers of this chapter. So today we have discussed Newton's third law of motion and law of conservation of momentum. Both are very important. So please go through it, do the derivation and ask me your doubts in the comment box. Till then, bye bye. Thank you for watching my video.